Bismillahirrahmanirrahim. Hello guys, now we will see how to implement PID controller in S7-1200 and TIA port version 14. So I have made a program already, so I will show you its features. Now here we have the PLC program block. Normally we have the OP1 block, but for the PID we need another block. So I have already created another block which is cyclic interrupt. How we will create it? We will create it at new block, and here we have the cyclic interrupt here. Now we will click OK and it will be added. So for the PID, first we need to have the analog IOs, analog input and analog output in our example case. Here the analog inputs and outputs are the previous experiment 4. Here we have the non-max and scale-x. So here we will be having the input IW64. That's the address of the input, analog input. So the address is normally shown here. If we click on device configuration, here we will be we can see the address 64656667. So 64 to 65 will be the address of first input, and for the other input we will have the address 66 and 67. There are two analog inputs in this CPU module, 1214 AC/DC relay, 1214C. So here we will be having the analog input value skipping from 0 to 27648, and from here we will be getting the value in 0 to 1, normalized value. Okay, from 0 to 1 it will then be further scaled. Here we are scaling it from 0 to 10, so we will be getting here 0 to 10 volts. Here we are actually also applying 0 to 10 volts here in the hardware. So okay, now I have created a run here to calculate the output. I am calculating the output by in this run by dividing the analog input with 2, input 1 divided by input 2. So I will be getting 0 to 5 volts in the output for 0 to 10 volts in the input. Now I want to show it to the analog output module, so I will first convert this value to 0 to 1, and then from 0 to 1 I will go to the raw value. So this run shows how to convert a value to the analog output port. So there is no analog output in the 1214C, but we have manually installed an additional block here. Show you this one, and this is basically your analog output, one analog output. We have this in our CPU in the lab, but I am here simulating it in the CPU. So now this is the experiment 4. So now in the PID, now this is the PID. Here is the experiment 5 has started. Now this is the PID component. How it is added? It is added here in the technology. In technology, we will be having PID control, and here is compact PID. We will choose this universal PID with integrated tuning. So that PID block will be here. Now it has many fields. We have to set these fields. For this, we will be having another PID block in the technology objects. So in technology objects, we will be having two, configuration and commissioning. First, we will go to the configuration. In the configuration, I have inserted the voltage value and automatic. For the input-output parameters, we need to define here what we will use. Here we will use this input and this output. Here we can choose the from two inputs. I have chosen analog. Here I have also chosen the output analog. However, there are three outputs: output preferred, output, and output speed up. Okay. Now process value limits are from 0, low limit is 0 and high limit is 10 volts, and this is the scaling from 0 to 10, scaling of low value and high value to the 0 to 10 volts. This is in PID, you have to configure it. Now we don't need to disturb these values, these are okay. Now PID parameters. Now these parameters are built-in parameters in the PID. These are basically the time, proportional gain, integral time, derivative action time. Again, please note that this is in the time, this is not the gain. So the equation would be of the PID would be in the time form. Okay. Now we can also enable our manual entry here. We can change these values. Okay. Now this is the configuration, and now on the commissioning part we will see its dynamic response. So first of all upload this program to the CPU. For this I need to run the CPU. Okay. Now I start the CPU, simulated CPU, as my computer is not yet connected to the CPU module. So I will download it. It's taking a little time. You have to be patient. Okay, load it. Now we can go online here. Now here we see that we have here IW, but I don't have here any CPU. So I will change this IW to MW to change it to the memory bit. So I am changing it. It will be changed here from the PLC tags. Go here and change this to memory bit. Okay, and this output, the output can be, there is no need here. Okay, so not here. Now here the CPU must be in the run state. Okay, now let me see it. Yes, now I can give the value like I give 20,000 here, and I have 7 volts here, 7.2 volts. Here I have half the voltage, 3.6 volts, and then 3.6 I again show it as on the same value. Here you can see here 20,000 we have given the input and 20,000 on the output. Basically we are giving the 10 volts as input, and it is also reading 10 volts on the output. Now please note that the output module we selected here, it can be in the milliamps and in the voltage. In the voltage the range will be 0 to 10 volt, in the milliamps it would be 4 to 20 milliamps. That can be selected from here. I can show you, it can be selected here, and here you can see the analog output, here the voltage. If the current is selected here, it's not showing because it's online. If the current is selected here, the analog output would have to be taken in current form. Now okay, we have configured our PID. Now we are going to commission it. So commissioning, we need to start commissioning, and now this is the commissioning has started, and start PID. So here we can see that we would be having current set point, stable volt, and output here. But here it is not showing because the CPU is not connected. If the CPU is connected, we will see the online trend. Here we will be having the input and set point and the output of the controller. So this is how we configure and commission the PID controller. So in the next video I will show you in the real time by connecting the CPU with this computer to show the dynamic response of the PID controller. Therefore, I am making this part as part 1. This part of the video as part 1. In the part 2, I will show you the actual response of the PLC by connecting it. So, thank you very much for listening.